So I guess you may start if you want.
Hello everybody. My name is Soubhi. The presentation will be about point cloud and mainly about point cloud library. So the structure of the presentation, first I will make a small introduction about point cloud. After that, overview about point cloud library. The structure, we'll go through about some of the features of point cloud library. I will explain to mesh layer application. After that, PCL installation, and I will finish with an example. So, what is point cloud? As we see from these two images, the point cloud is a kind of data structure to represent a collection of multidimensional points, mainly in 3D points like X, Y, Z. So it represents 3D information about the world. Each point can consist of 3 coordinates, X, Y, Z, and moreover it can consist of intensity, RGB, distance, so it may contain more information. So here another examples about point cloud. In the left image we have some color point cloud. Here on the right we have intensity point cloud, so it's like somehow a gray image. So each point cloud here contains X, Y, Z and intensity. So how is point cloud generated? Mainly using some hardware sensors like stereo camera. You know that we need 2 cameras to get the distance of the object. So these 2 cameras called stereo camera. So using stereo camera we can get point cloud, using 3D scanner, using time of flight cameras, kind of cameras, and finally using some software programs like Maya, Blender, or 3D Max. So using these programs we can generate point cloud. So like in this image, here we have this 3D scanner which will generate a point cloud about this object. And these cameras, it's a distance camera. I guess it's real scenes camera from Intel. So using this camera we can get a point cloud for the view or the object in front of the camera. So now the main topic of this presentation, PCL. So PCL is an abbreviation of Point Cloud Library. So what is PCL? PCL is a large-scale open source for 2D and 3D image and point cloud processing. So it's not just for point cloud, it's also for 2D image processing. It's cross-platform. That means you can use it on Windows, Mac, Linux, whatever operating system. I guess it's a little bit difficult to run it on mobile platforms like Android and iOS because it has some dependencies. So it's a little bit difficult, but I tried it on Windows, Mac, and Linux, and it was perfect. It contains many or numerous state-of-art algorithms in filtering, feature estimation, surface reconstruction, registration, segmentation, and many other features. I will go through some of them in this presentation. And finally, it's under BSD license. So it's open source and it's free for commercial and educational use. So here's some example about the feature I will introduce later. So who is developing PCL? You know that when you want to use some tool, you have to know the support, who is developing in it. So it's an important issue. So many organizations all around the world, including, as you notice, NVIDIA, Intel, Google, so it's really a famous and many developers all around the world developing this library. So who is financially supporting PCL? Again, many big names here like Toyota, NVIDIA, Google. So after these 2 information, we have an equation that it should be a stable algorithm because it's supported financially and supported from many developers all around the world and from big companies. So the structure of PCL PCL consists of, it's a huge library, but actually it consists of some of small libraries, so we call it modules. So it's an organized library. You can just combine whatever you want. So here, for example, we have the main module called common. So if you want, for example, to do segmentation for the point cloud, so you just need this module, segmentation, and common segmentation module. If you want, for example, to use some optimization algorithm that is in CADE 3 to do segmentation, so you have to combine both of these algorithm modules with this one. So it's organized in a good structured way. So it consists of some small libraries. So the main element in PCL is the point. So what types of points do we have? We have the first one, x, y, z. So just the coordinates for the point. So it's either white or black, white for the object and black for any other thing. We have x, y, z, and I for intensity. Another type for color, RGB, and we have many other types like normal. Normal contains information about neighborhood, curvature, so it's also an important type. Finally, if you want to develop or define your own type, you can just use quantity template because PCL is a C++ library, so you can use this template to define your own point type. So now we will go through some of the modules and features inside PCL. I would here to concentrate that I will just explain some of the modules and some of the features because it's a huge library and I don't have experience for all the features in this library. So as we said that PCL is split into many modules like filters, features, keypoints, registration, and all other modules. So when I was preparing for this presentation, a question came to my mind. What's the difference between the feature and keypoint? Anyone have an answer for that? The difference between features and keypoints. Because PCL has features module and keypoints module. So after I did some search, the feature itself consists of keypoints and descriptor. So you can consider it as the output of SIFT algorithm. But for keypoints, it's just the points without the descriptor. So you can consider it as a corner, the output of corner filter, for example. So PCL consists of these modules. Again, this the graph that shows the connection between these modules. The first modules, and one of the most important modules in PCL, the filters. We can use this module for noise removal, as we see here. So here, as we notice here, we have a lot of noise and outliers. Using some filters in this module, we can get these results, a clean point cloud. So any points don't meet any criteria or any condition will be removed. The other important filter is called voxel grid filter. We use this filter to downsampling the point cloud. So as we notice here, we have here a rigid object, point cloud. Here, this is the output of the algorithm. So we have downsampling point cloud. So someone may ask, why do we need to downsample the point cloud? Because the point cloud consists of hundreds or thousands of points. So the processing is really heavy. So we should be careful about the number of points. And maybe sometimes some samples are enough to do the processing. In the other way, if you want to do 3D scanning to build an 3D object for, you are building your 3D scanner, you want to build rigid body. So yeah, you don't need to use this filter. And even you have to use some filters to do reconstruction for the missing surfaces. So this is the second filter. It's called voxel grid to do downsampling. The third one is some statistical outlier removal. So it's the same of the first type. It's used for delete or to remove some outliers or some noisy points using some statistical methods. So the second module, it's called segmentation. And as we know, the idea of segmentation to separate objects in the scene, as we notice here. Here, the surface of the table and the table, the ground. So in this segmentation, there are many state-of-art algorithms for segmentation, and it's optimized to work with pointed cloud. So, for example, here the output of this on the right, the output of this algorithm, this used cylinder module segmentation, but this used plane module segmentation. So there are many methods to do segmentation, and mainly it's used clustering. The third module is called service. So this module is very useful when we want to build or do reconstructing for missing part. So you can do this. The algorithm can do that using the information from neighboring point cloud, neighboring points in the point cloud. So, for example, here in the right we have an image for point cloud, and this is a zoomed image. So we notice that here the connection between the points is like triangles, because here we used a filter, or not a filter, an algorithm, surface triangle algorithm to do reconstruction for missing parts. So surface contains many algorithms to reconstructing. Another function exists in this module. It's called get the 2D HAL algorithm from 3D point cloud. So what's the benefit of this module? For example, if you want to simplify the surface representation, you can use it. If you want to get the boundaries of the point cloud, you can use this filter.
No, I just found the bottom of there.
The third important function in this module is you can build from, for example, this point cloud. It's not a rigid. You can get a smooth and rigid surface using some algorithm called B-spline. So this module contains many algorithms, and it's really helpful for reconstructing missing parts. The next module is visualization. Again, an important module. So this module helps us to get to view the point cloud, to see it in a 3D environment. It's somehow similar to a high GUI function in OpenCV when we call IMShow. So, for example, this is an example about the output of visualization module. You can show the object in 3D, and you can drag using the mouse and rotate, zoom out, zoom in. Another functionality is to draw some 3D basic shapes like surfaces, shapes, spheres, circles, cylinders. So you can use these polygons. You can draw these polygons using visualization module. You can even plot some histograms. You can show some range images that contains information about the distance. The other module is called I/O, input-output. From the name, it's obvious that it's related to reading and writing point clouds. So it contains functions to write and read point clouds from the disk. By the way, there are many extensions for point clouds like OBJ, PLY, BCD. So there are many. Almost all of them are supported from PCL, so you can use any of them and do processing on it using PCL. You can use this module to capture point cloud, for example, to trigger the camera to get point cloud. So the unique here that BCD format, it's not, I mean, a general format for point cloud. It's developed in PCL, so you cannot use it in other 3D software like Maya or Blender because it's not supported. So why did they develop this point cloud? Because it's optimized to work with the algorithm in PCL. It's called an organized point cloud. It has some format which is optimized to work with point cloud. So the format is simple. Here there are header contains some information like version, fields. Here we have XYZ and RGB. So here the point is the type XYZ RGB. So here the information about the header, and after that the information about the points. So if you want to work with PCL, it's recommended to use BCD. But if you want to use other types of points clouds extension, it's supported. So now I will introduce MeshLab. MeshLab is a software you can use it to do some processing and show point clouds. It's available on Mac, Windows, Linux, and it's open source, so you can just clone the source and build it. You can use it. The main function here to use it to show the points. So this is the screenshot from the application. So, for example, if you are building an autonomous system on a rover, and the rover should avoid obstacle, but it collides with the obstacle. So you want to get out these point clouds from the rover and to see the output, why the collision happened. So you can use like this application to track to see the point clouds. So now we want to drag and drop PCD file in MeshLab. Oops, it's not supported. So now that will lead us to make a small example to convert PCD to BLY. So first we have to install PCL. PCL actually depends on some 3D party libraries like Boost. Boost is one of the most famous library in C++. Eigen, it's lightweight header libraries for eigenvectors. It's anything related to vectors. And if you have OpenCV installed, it's already installed with OpenCV. Flan is a library for some algorithm, optimization algorithm, depending on neighborhood information. And finally, VTK. VTK is a library for visualization. So if you want to use visualization method in PCL, you have to install VTK. If you don't want to use it, so no need to compile and install VTK. You can use pre-built libraries, pre-built binaries. So you can just, for example, for Windows, do next, and get the library, or you can build it from source. So if you want to use pre-built libraries, here you will lose all the options you want to do. For example, you cannot choose, I want to compile this and not compile this. But if you want to build it from source, you have all the options to check in or check out. So to build it from source, which is recommended for us as a developers, first to clone code from GitHub, and second, PCL relies on CMake. CMake is a tool for C++ to make the configuration and build the library. So here we have this application. It's called CMake GUI. You can use it to do the configuration for the building. So first, here we have to browse for the source. So here we clone the library. Second, here we have to choose the build folder, the output. So we want to put the output in a folder called _build. Usually, developer called it _build. I don't know why underscore, but it's familiar with developer. Third, you press here configure. So after that, you press advanced. So all these options will show for you. So for example, here we notice that PCL is can work with CUDA, so it can work with GPU. We notice that there is many options, so you can check whatever you want and check out whatever you don't want. For example, here input output, you can enable it or not. There is registration. This module, I didn't talk about this module, but this module is really important. If you have many point cloud for the same object in different angle, you can use this module to do registration and to put these points cloud on each other to build a complete scene, like in what we are doing in homework 5 in 2D images. So after that, after we finish choosing the options, we press configure and generate again. So now we go to the folder here where we put the output, and using command line we execute make. It takes usually long, more than half an hour, but if you reduce the number of modules, for sure it will take less. So after that, the libraries, the binaries, and all the libraries will be in underscore build folder. If you want to install it in your system, type or execute make install in the command line. So after that, you should have all these files in your system. The first one here is a configuration, CMake configuration files. It should be in something related to user, either in Linux or Mac. The second one is the headers for PCL. So here we notice all the files ends with .h, and here the libraries. In Linux it will be so.so.a, so for shared libraries and .a for static libraries. So now the PCL is installed in our system, so let us develop a small application. The application is to convert BCD to BLY. So the main code, the main.cpp code, first here we include all the libraries. So for example, from our input-output module, we include BCD.io and BLY.io and some other helper headers. And here in the main, we just load or read the BCD point cloud, and we again write it as a BLY point cloud. So here just load BCD and write. It's very simple. So now we finished the C++ main code. So if you are using some IDEs like Visual Studio or Eclipse or NetBeans or whatever, you have to link the libraries and the header with the project. But if you want not to use such like application, you can create a simple CMake file like the one in PCL. So this is a simple CMake for our application. First here we have the version of CMake, and we are using C++ 14 standards. Here the name of the project, PCL example. We find package PCL, it's required, so if PCL is not installed in our system, it will fail. This will search for PCL in our system. Here we link the layers, the headers and libraries with the project, and finally we link it with main.cpp. Again, after that we'll use CMake GUI. The same steps. First we browse the code, we set the output, configure and generate, make. Finally we get the exe or executable. In Linux and Mac there is no exe, executable application. So we just run it using command line, and this is the output. So this is the output of our algorithm, or this is the output of PLY point cloud, and we show it in MeshLab application. So using MeshLab you can zoom in, zoom out, and even do some modification to points you can make change the point size. So if the point cloud is already down sampled, so you can open it in MeshLab and change the point size. The resources I used PCL official website and MeshLab. I uploaded the example on GitHub, and thank you. That's it.